Hello, hello, and welcome to this video. So, as I said in my last video, when I made video about dbeaver and SQL tools of VS Code extension, I said that I will alternate videos between theory and practice. So, we have a theory video here. We are going to read the documentation of date and time types. So, it is a very important video. There are two reasons why. One is that we need to know the limits of these data types. And second is the fact that whenever you will create a table, there will be usually two columns. One is created at, that is when the row is created, and second is the updated at column. There could be a third column as well. For example, expired at. I'll give you an example. Suppose that for login, you send an OTP to the user and OTP expires in say 5 minutes. Now PostgreSQL does not have a mechanism to expire the rows. So what you can do is you can have a column created at and then you define a column expired at. And while defining the table, you can say use an interval to set the expired at column to be after 5 minutes than created at. So that way, when you want to query, you can look at expired column and see that 5 minutes have elapsed or not. And then accordingly, you can say that OTP is expired or not. The second thing you can do is you can run a cron job, which will look at created at column and expired at column. And based on that, it can clean up the rows of OTPs because you don't want them to accumulate all the time because it is unnecessary to keep those in databases. So that is the basic usage I have told you about. Similarly, if you are building analytics software, data and type is very crucial, or you want to implement a time series database inside PostgreSQL, then also date time types are very crucial. One of the examples of time series databases could be, suppose, for example, you have a cloud website where you have the graph of CPU, memory, network, and disk consumption. You are plotting a graph, so the graph could be of 24 hours, and then you don't need data before that. So you want only 24-hour data, so you can keep putting in data from one side, and then you have an interval column. And based on that, you can pull out 24 hours of data, and you can again have a cron job, which can remove the data. So that is one example of a time series database. Now we will just go through the documentation. So date and time types, we have certain columns. We have name, storage size, description, low value, high value, and resolution. So the first row is timestamp. P is precision without time zone. So this is a timestamp which does not know the time zone of the clock. So storage size is 8 bytes. Description is that it contains both date and time, but no time zone. Low value is 4713 BC, and high value is 294,276 AD, and resolution is 1 second. You will also notice here in the description is that dates are counted according to the Gregorian calendar, even in the years before the calendar was introduced. I don't know when it was introduced. It was sometime around 17th, 18th century. That's when the calendar was introduced. Now, the second row is timestamp with time zone. Again, 8 bytes contains date and time, which time zone, limits are same, resolution is same. Then we have date, data type, takes 4 bytes, no time of the day, it contains only date, limit is 4713 BC, lower limit, upper limit is 5,874,897 AD, and resolution is of course 1 day. Then we have time with precision and without time zone, 8 bytes, time of day, it does not contain date. The lower limit will be of course 000 and upper limit would be 24,000 and resolution is 1 microsecond. Then we have time with time zone, which contains 12 bytes. So it contains time of day with time zone. So it would be 000, and then the time zone information. This is time zone information, and the resolution is 1 second. Then we have interval, which will take precision and fields. So 16 bytes, and it contains time interval. And let me read this. See, it's 6 minus 178 million years up to 178 million years, and the resolution is 1 microsecond. Now we have a note here. The SQL standard requires that writing the timestamp equivalent to timestamp without time zone, and PostgreSQL honors that behavior. Timestamp Z is accepted as an abbreviation for timestamp with time zone. This is a PostgreSQL extension. So in general, you don't need to specify the time zone when you put it in table, because it will automatically take the time zone of the server. And once you have date time information with any time zone, you can easily convert it to any other time zone in the programming language you are programming. So timestamp, and interval accept an optional precision value p, which specifies the number of fractional digits retained in the second field. By default, there is no explicit bound on precision. This allowed range of p is from 0 to x, because the resolution is of 1 microsecond. So the range of t is 0 to 6. The interval type has an additional option, which is to restrict the set of stored fields by writing one of these phrases: year, month, day, hour, minute, second, year to month, day to hour, and so on. Note that if both fields and key are specified, the fields must include second, since the precision applies only to the second. The type time with time zone is defined by the SQL standard, but the definition exhibits properties which lead to questionable usefulness. In most cases, a combination of date, timestamp without time zone, and timestamp with time zone should provide a complete range of date time functionality required by any application. So we look at how we input this. Date and time input is acceptable in any reasonable format, including ISO 8601, SQL compatible, traditional Postgres, and others. So we will skip this. We don't care about much, because we are going to stick to ISO 8601 time standard, and you will see how it works. Okay. So you can read this if you want, but we are going to skip it. And dates, we have some example of dates. So we are going to stick to ISO 8601. So 8th January is written like YYYY MMDD. We don't care about other modes. You can read for reference, but we don't care about it. Okay. Once you have ISO mode, the reason is why ISO mode I'm talking about is because that's the standard, and it will be usable across many programming, almost all programming languages. I don't know of any programming language which does not support this, unless that language is from the archaic ages. Now we look at times. The time of the day types are time with precision and without time zone, and time t with time zone. Time alone is equivalent to time without time zone. Valid input for these types consist of a time of a day followed by an optional time zone. If a time zone is specified in the input for time without time zone, it is silently ignored. You can also specify a date, but it will be ignored, except when you use a time zone name that involves a daylight savings rule, such as America/New York. In this case, specifying the date is required in order to determine whether standard or daylight savings time applies. The appropriate time zone offset is recorded in with time zone value and is output as stored. It is not adjusted to the active time zone. So you can look at ISO 8601 ways of specifying time. So we'll stick to this, because that's how we want the specification to work. This one does not have the microsecond resolution, this one does not have seconds, and this one does not contain the delimiter. You can use any of these, because all are ISO 8601. We don't care about non-ISO formats. These are ISO formats. So we honor those time zones. And then we have time zone inputs. You can have PST, you can have America/New York. So in general, this one is preferred because it is also part of Linux operating system. And this one is also good because it is explicit in nature. Now we look at timestamps. Valid inputs for timestamp types consists of the concatenation of a date and time, followed by an optional time zone, followed by an optional AD or DC. So we can have this, or we can have this. So it is date and the time zone. Okay. Now you can write like this also, but we care only about time zones. So for example, these are also correct. Okay. So now we read this documentation. And a value that has been determined to be timestamped without time zone, PostgreSQL will silently ignore any time zone indication. That is, the resulting value is derived from the date time field in the input string and is not adjusted for time zone. For timestamp with time zone values, an input string that includes an explicit time zone will be converted to UTC using the appropriate offsets for that time zone. If no time zone is stated in the input string, then it is assumed to be in the time zone indicated by the system's time zone parameter and is converted to UTC using the offset for the time zone. In either case, the value is stored internally as UTC and the originally stated or assumed time zone is not retained. When a timestamp with time zone value is output, it is always converted from UTC to the current time zone and displayed as local time in that zone. To see the time in another time zone, either change time zone or use at time zone construct. Convergence between timestamp without time zone and timestamp with time zone normally assumes the timestamp without time zone value should be taken or given as time zone local time. A different time zone can be specified for the conversion using at time zone. Now we look at special values. So there are several special values. The values infinity and minus infinity are specially represented inside the system and will be displayed unchanged. But the others are simply notational shorthands that will be converted to ordinary date time values when read. In particular, now and related strings are converted to a specific time value as soon as they are read. All of these values need to be included in single quotes when used as constants in a SQL command. So one is epoch, which all programmers know, that is the midnight of or beginning of 1970 year, 1st January of 1970 at midnight. Infinity and minus infinity are special. So infinity is later than all timestamp and minus infinity is earlier than all other timestamp. That is, once you go beyond the limit, they become infinity. Now is the current transaction start time. Today is midnight, tomorrow is tomorrow's midnight, yesterday is yesterday's midnight, and all balls is 00 UTC. The following SQL compatible function can also be used to obtain current time for the corresponding data type. Current date, current time, current timestamp, local timestamp. So these are SQL compatible functions, which we will also see later in when we read chapter 9. Note that these are SQL functions are not recognizing data input strings. Caution. When the input string now, today, tomorrow, and yesterday are fine to use in interactive SQL commands, they can have surprising behavior when the command is saved to be executed later. For example, in prepared statements, use and function definitions, the string can be converted to a specific time value that continues to be used long after it becomes stale. Use one of the SQL functions instead of such context. For example, current date +1 is safer than tomorrow date. The reason is mentioned here. Okay, I read it. Yeah. So where was that? I read it. So when the transaction begins at that time, it is evaluated. Okay. And so, for example, tomorrow date, if you specify, then it will be evaluated at particular time. And if the transaction is not applied, then the date will be stale. But if we say current date plus 1, then it will be always tomorrow. Now we look at DateTime output. So these are the formats of DateTime output, and we are interested only in ISO 8601 because that's what most programming languages support. You can write your own process for other types, okay? So we don't worry about that. ISO 8601 specifies the use of uppercase letter T to separate date and time. PostgreSQL accepts that format on input, but on output it uses space rather than T as shown above. So in output, there is no T here, but in input, there should be a T. Okay, this is for readability and for consistency with RFC 3339 as well as some other database systems. In SQL and Postgres style, they appear before month if DMY field ordering has been specified. Otherwise, month appears before day. So we in general use ISO. So in ISO, it will be YYMMDD. Now we look at date order conventions. We don't worry about this. It is not very useful. Now time zones, I don't think we need to care about this a lot, but you must be careful with the time zones which have daylight saving time because that can cause surprises. But in general, let PostgreSQL handle this. Okay. There is not much useful information here because internally it is UTC. Now we look at important part, that is the interval. So interval has following syntax: optional at the rate, quantity unit, and direction. The quantity is possibly signed, unit is microsecond, millisecond, second, minute, hour, day, week, month, year, decade, century, millennium, or abbreviations or plural of these units. Direction can be ago or empty. The at sign is optional noise. Amounts of different units are implicitly added with appropriate sign accounting. Ago negates all the fields. This syntax is also used for interval output if interval style is set to Postgres verbose. Quantities of days, hours, minutes, and seconds can be specified without explicit unit marking. For example, 1 space 12 colon 59 colon 10 is read as 1 day 12 hours 59 minutes 10 seconds. Also, a combination of years and months can be specified with a dash. For example, 200 years and 10 months is read as 200 years 10 months. These short forms are in fact only ones allowed by the SQL standard and are used for output when interval style is set to SQL standard. Interval values can also be written as ISO 8601 time intervals using either the format with designators of the standard section 4.4.3.2 or alternative format of section 4.4.3.3. The format designators look like this: T quantity unit, T quantity unit. So the abbreviations are given here: Y for year, M for month, W for week, D for days, H for hours, M for minutes, and S for seconds. So in alternative format, it could be P years, month, days, T hours, minutes, second. The string must begin with P and P separates date and time parts of interval. These values are given as numbers similar to ISO 8601 day. When writing an interval constant with the field specification or when assigning a string to an interval column that was defined with the field specification, the interpretation of unmarked quantities depend on fields. For example, interval 1 year is read as 1 year, whereas interval 1 means 1 second. Also, fields value to the right of the least significant field allowed by the field specification are silently discarded. For example, interval 1 day 2 colon 03 colon 04 hour to minute results in dropping the second field but not the day field. According to the SQL standard, all fields of an interval must have the same sign. So a leading negative sign applies to all fields. For example, the negative sign in interval little -1 to colon 03 colon 04 applies to both the days, hour, minute, and second parts. PostgreSQL allows the fields to have different signs and traditionally treat each field in the textual representation as independently signed, so that our minute second part is considered positive in this example. If interval style is set to a SQL standard, then the leading line is considered to apply to all fields, but only if no additional signs appear. So be careful about putting signs in the field. Okay, don't make it too complicated, otherwise you will always get confused, and people who will read your queries will get confused. Otherwise, the traditional PostgreSQL interpretation is used. To avoid ambiguity, it is recommended to attach an explicit sign to each field if any field is negative. Internally, interval values are stored as three integers: field, months, days, and microseconds. These fields are kept separate because the number of days in a month varies. While a day can have 23 or 24, 25 hours if a daylight saving time condition is involved. An interval input string that uses other units is normalized into this format, then reconstructed in a standardized way of output. So the key point to notice here is that when the daylight saving switches, the day can have 23 or 25 hours. So that is a point which should be taken care of when you are talking about interval. Now we know this. Okay. So these are some examples of interval inputs, and then we have interval outputs. Okay. As previously explained, PostgreSQL interval values as months, days, and microseconds. For output, the month field is converted to years and months by dividing by 12. The days field is shown as it. The microsecond field is converted to hours, minutes, and seconds, and fractional seconds. Thus, month, minutes, and seconds will never be shown as exceeding the range 0 to 11, 0 to 59, and 0 to 59, while the displayed years, days, and hours field can be quite large. The justify days and justify hours functions can be used if it is desirable to transport large days or hours value into the next type field. The output format of interval type can be set to one of the four styles: SQL Standard, Postgres, Postgres Verbose, or ISO 68601 using the command set interval style. The default is the Postgres format. Table this shows example of each output style. So when you are querying, you should always set this to ISO 601, okay, to this set interval style. Okay, you can set it into your Postgres configuration as well, I believe. The SQL standard style producer output that conform to SQL standard. So it is basically the description of this table and nothing more. So we'll stick with the ISO 8601 in general. If you don't set it, it will be Postgres version also. We can stick to Postgres also. And we will actually use Postgres because in general, when working, we don't set this interval style. So it is beneficial, it could be beneficial to use the PostgreSQL style. So for these also, you can study the PostgreSQL standard as well. So next topic is Boolean values, and I will stop here. Booleans we will see in next video. So I hope that you have found this video useful and informative. If so, please subscribe to the channel and like the video for two reasons. One is that if you like and subscribe to the channel, the reach of video increases because that is how the YouTube algorithm works. And second is the fact that it motivates me to make more such videos. So thanks a lot for watching. Happy to be done.